Hello students, I am Dr. Ritu Agarwal from Department of Electronics and Communication Engineering. Today I would be discussing combinational circuits in the lecture series of Digital System Design. So in the combinational circuits, we would be covering different circuits like half adder, full adder, half subtractor, full subtractor. And today we would be starting with the concept that what is a combination circuit. Combination circuit is a combination of different types of logic gates, input variables and output variables. So here you can see the block diagram of combination circuit in which we have shown the combination circuit block diagram with n number of input variables and m number of output variables. There are various applications of combination circuits. Combination circuits are commonly employed in modern technologies due to their simplicity and ability to provide instant output. Some of the applications are discussed below, like arithmetic and logic unit, ALUs, which are being used in computers, data encryption and decryption, data multiplexing and demultiplexing, traffic light control, and many other various applications of combination circuits are there, which we can use in daily life or day-to-day life. So there are various types of combination circuits. Few important standard circuits are half adder, full adder, half subtractor, full subtractor, encoder, decoder, multiplexer, and magnitude comparator. We would be discussing these standard circuits in our lecture series in further lectures. So today we would be discussing the first combination circuit, that is a half adder. So what is a half adder? Half adder is a combination circuit in which two bits are added. It has two input bits and two outputs as sum and carry. So we would be starting with the truth table of half adder, in which we have two input variables A and B and two outputs, that is sum and carry. With two input variables, we would be having four possible combinations of inputs, that is 2 to the power n, where n is the number of inputs. That is, here we have two inputs, so we would be having 2 to the power 2. That is, four possible cases are there. So for the first combination, is A and B have 0, 0 as the inputs. So the sum will be 0 plus 0, that is equal to 0, and carry will also be 0. For the second one, we have 0 as 0 and 1 as the inputs. So 0 plus 1 will give sum as 1 and carry as 0. For the third input, 1, 0 are the inputs. So the sum will again be 1 and carry will be 0. And the last combination is 1, 1. So 1 plus 1 in binary gives us 1, 0. So the sum will be 0 and carry is 1. Now to plot the circuit, we would be having the K maps for half adder, and for since we are having two outputs, one is for carry and one is for sum, so we would be having two K maps also. So for carry, we have one K map in which we have only one output as 1 for A and B equal to 1, 1. Therefore, carry will be equal to A into B. And for sum, we would be having A XOR B. That is A B bar plus A bar B. So taking these two outputs as sum and carry, we can draw the circuit of half adder. So here is the logic diagram of half adder, in which we have sum as A B bar plus A bar B, that is equal to A XOR B, and carry equal to A into B. So here in the logic diagram, you can see that sum or S, in which we have A and B as the inputs, and they are being given to the XOR gate, and from the sum output is taken, which is A XOR B. And for the carry, since we are having the ANDing of A and B inputs, so the output would be A into B. So this is all about our half adder circuit, in which we can add two input bits. So these are the references which we have used. Thank you.